Alright, friends, welcome to part 6 of our lectures Becoming a LEED Green Associate. In this part, we'll be discussing sustainable site. Let's go. So, for content, we'll be looking at sustainable site overview, sustainable site, the topic of design and construction, operations and maintenance, the heat island effect reduction, rainwater management, and light pollution reduction. Now, in understanding sustainable sites, this refers to the relationship between a project and its surroundings. It's essentially about how building interacts with the ecosystem, neighboring structures, and also the site elements. It is important to find synergies between the current situation of a project site and the proposed strategies for sustainability. Now, there are measures that have been designed under the sustainable sites category to promote the triple bottom line benefits. And I'll mention the 5 of them as we proceed. The design and construction strategy, operations and maintenance strategies, the reduction of heat island effects, management of rainwater, and light pollution reduction. For design and construction, this focuses on the engagement of best management practices during design and construction stages. Ability to understand the existing features of a site, helping the project team to identify specific strategies to implement all through the construction phase of the project. Now, the triple bottom line benefit for sustainable benefit has to do with minimizing pollution, limiting disturbance to wildlife and natural habitats, preserving the ecosystem, and mitigating impacts from construction activities. Economically, while the initial cost may be a little bit higher, the heat island effect can be reduced through the use of light colored paving. This lowers temperatures and by so doing reduces the need for air conditioning systems. Also, effective management of water runoff will limit the chances of damaging natural plantings and vegetation on site. At the end of the day, operational costs in the long run will be reduced. And of course, socially, when the ecosystem is healthier, the health conditions of the people is also better. So a healthier ecosystem is a healthier people. Now, we have the site assessment, which is a key strategy. This talks about performing site analysis before a design. So give us opportunity to understand the site conditions and strategies for sustainability. On various disciplines are involved in this assessment process, and this helps us to reduce cost by the synergy, to minimize risk as they would have been mitigated, thereby promoting the health of the occupants and preserving natural features. Now, under the site analysis, a number of areas, and you need to take note of this, must be captured. One, the topography of the site. Are there steep slopes? What is the direction of overland water flows? What are the contours of the site? Secondly, hydrology. How do we develop a sustainable approach to managing rainwater? And this helps us, to ensure that flood hazards are reduced and that we're able to manage water effectively for either landscape activities and so on. Three, that must be included in the site analysis report is the climatic conditions, which essentially is to drive the possibility of incorporating passive design strategies, including taking a study of the temperature, the relative humidity, solar exposure and access, intensity precipitation, and also the prevailing winds. Every component of the climatic conditions that can inform decision making when it comes to design. Number 4, vegetation. Take a study of the significant trees, the invasive plants, the native plants, greenfield areas, local wildlife, and also the habitat corridors. This information would help you to plan your landscape design, the plan for irrigation, and so on. Soils. Identify healthy soil and determine the site soil classification. This is also important in planning for your green build. And then what kind of built environment surrounds the site, including infrastructure and so on, transportation, facilities, and the likes. Right? Number 7, human health effect. This is to evaluate the opportunities for physical activity that exist on the site or adjacent to the site. And also, these 7 comprehensive components must be present in the site assessment is done. Now, upon the completion of the site analysis, the site assessment, now we can talk about the site design. This should involve best management practices and engaging information already harvested from the site analysis so as to optimize the benefit that may accrue. Now, there should be competence in understanding the difference between project boundary, that is the definition of the extent of the ongoing development. The LEED project boundary defines the area that is being presented for LEED certification. The affected properties, the supporting facilities that are linked to providing all the essential services for your green building defines the LEED project boundary. We're going to be seeing an illustration of this in the next slide. Then the property line is essentially the extent of the property owned by the entity. This is important now. The property area of land refers to the legal boundary of a land parcel. The project boundary refers to the perimeter that defines the developed and undeveloped areas that are part of the scope of work. The lead project boundary, like I said, refers to the portion of the project site that is being submitted for lead certification, right? Developed areas are the part of the project site that you need to take those of these keywords and what they mean. So, developed areas is the part of the project site that is affected by any development and altered from its original purpose. And of course, the building footprint is the part of the project site that is actually used by the building structure. Of course, the development footprint, any area that is impacted by any of the development is the development footprint. This is the illustration I made reference to earlier on. You can see what I explained about the lead boundary line, the property boundary line, and also the building footprint line. Then this speaks to it very clearly. Now, landscaping. Beyond the design of the building, particular attention must be paid to landscaping under the sustainable site category. This is to guide the utilization of particular plantations and vegetation in view of the impact they can have on various sustainable factors. Appropriate selection and placement of plants to enhance the overall sustainability of the site design is the focus of sustainable landscaping. And this is facilitated by selecting native plants that are used to the region, by so doing requiring less water. Now, we also have what we call adaptive vegetation. This kind of plant can survive in harsh environments with minimal water consumption without harm to the surrounding vegetation. But there's what we call invasive plants. So you should take note of adaptive native vegetation. They are indigenous to the region. Adaptive vegetation, they can cope in that region without much consumption of water. But invasive plants tend to aggressively spread and take over the neighboring plants. So that's why attention must be paid to the choice of plants and even their placement on the site. Finally, for this landscaping section, xeriscaping, a word you should pay attention to, is a landscaping method that minimizes or eliminates the need for supplementary or supplemental irrigation. So this is a sustainable alternative to the traditional landscaping. So this is a key feature of the sustainable sites category. Now, we also have another strategy here: maximize open space. Maximize open space. Open spaces encompass areas that feature permeable surfaces or are covered with vegetation and plants. team are encouraged to take advantage of open space areas because of the numerous environmental benefits that they offer, one of which is the reduction of heat island effects. Open spaces such as gardens, recreational areas, vegetated roads, what we call green roads, gives opportunities for occupants to connect with nature, which improves their well-being and productivity. Is a key feature of the sustainable site category. Is a key feature that you must pay attention to. And as we go on, you understand what qualifies for open space and what does not. Again, for sustainable sites, you have to minimize construction activity pollution. We mentioned that construction sites pose a lot of environmental threats that can have serious consequences, including health hazards for individuals, polluted water streams, damaged vegetation, dusty streets, and even accidents in densely populated areas. So, LEED has methods proposed to mitigate construction pollution and prevent it from spreading beyond the project site boundaries. Now, take notice of the reference standard shown up here, which is the CGP. The CGP means Construction General Permit. That is the reference standards for compliance on the minimized construction activity pollution strategy. Take note of that. You may come across it in your. Now, we also have restore and conserve sensitive areas. Now, this is still under our design and construction strategy of the sustainable site. Now, this is the sixth strategy. Restoring natural habitats on project sites offers the environment and society benefits by improving the habitat and biodiversity. So, there's the need to identify sensitive areas such as soils, native vegetation, and wildlife corridors in order to provide for their successful restoration and repurposing of areas similar to the original state. The first step to achieving this is identify the areas of utmost importance for the protection of various species. This is essential with a focus on limiting disturbances and minimizing the need for additional soil and habitat restoration. This is a key strategy for sustainable site design and construction. Identify sensitive areas and making efforts to either preserve, restore, or repurpose them, as the case may be. Seventh key strategy: brownfield and infill development. A brownfield site refers to a land that has been previously utilized for industrial or commercial activities. Some may have resulted in the contamination from hazardous waste or pollution. So, in view of this, the first thing to do on the brownfield site is to conduct site assessment to investigate such facilities or such lands. Right? LEED certification advocates for the remediation of brownfields and the development of infill projects. They are not to be left abandoned. They should be converted to preserve greenfields, right? So this is another area where sites are prepared to be sustainable because this prevents the spread of contamination beyond um, the damaged lands once they have been restored for newer projects. And then it also helps us to have, like we said in previous chapters, compact development and ability to link up with already existing infrastructure that we are servicing the initial purpose of the brownfield. Now, this is a call out of something about a brownfield, the land that is ripe for recycling. And you can see here, it says a brownfield site here marked for 127 new homes, right? 127 new homes. And imagine how much land, how much greenfield, how much prime lands would have been required to erect a facility for 127 new homes. But this is a case of a brownfield site surrounded by fully developed terrains and existing infrastructure that is now being converted for 127 new homes. So the environment is the winner in this case, and that is the goal of LEED certification. Number 8, environmental site assessment. Now, this is a report that examines a land area. Remember, we said site assessment is key to understanding the condition of a land. So, this is the report that tells us if there are potential existing environmental contamination hazards. And the land itself will be assessed, including the physical improvements to the project land. And so we have the phase one ESA, which is the environmental site assessment, a qualified professional, as described in the ASTM E1527-05. Now, this is another reference standard for phase one ESA. The reference standard for phase one environmental site assessment must comply with the ASTM E1527-05. Pay attention to this. And if contamination is found from the ESA phase 1, then phase 2 is recommended, which is the phase 2 of the ESA. And the reference standard which guides the phase 2 environmental site assessment is the ASTM E1903-11. ASTM E1903-11. You want to pay attention. Don't forget I told you at the beginning of this lecture that we have a bonus chapter that will tell us all the key words that we have vested from every chapter, from chapter 1 to 10. All the keywords that have been invested, we will show them to us at the end of this lecture. And then that will guide us in our study plan, knowing that the identification of the keywords takes you closer to an understanding of the content of the lecture. Let's go ahead. We have site operations and maintenance. Don't forget, we've talked about design and construction. Now we're talking about the second strategy under sustainable site, the second category under sustainable site. is the site operations and maintenance. Essentially, this is about creating a site management policy that evaluates current practices and sets the standard for future practices, which are called goals and objectives. The triple bottom line benefits cannot be overemphasized, and you can see them on the slide. How is this approached? Now, a number of strategies for operations and maintenance, and that is number one, the building exterior management plan. To maintain the building's exterior, landscape, landscape, minimizing environmental impact. While at this, there's need to create a comprehensive plan using effective management practices. Now, that plan needs to put the following into consideration. I mentioned the five of them. Ensuring energy efficiency by monitoring and tracking all machines and equipment. Right? Secondly, reducing potable water use and taking advantage of rainwater harvesting while also monitoring current strategies to conserve water. Number three is to ensure that the outdoor air quality is enhanced by using zero emitting materials that have low VOC limits and low toxic content. Of course, you already know we talked about VOC earlier on as volatile organic compounds. Number four, maintaining a safe and comfortable environment by ensuring pedestrian access and safety. Right? And five, using environmentally friendly cleaning products with zero toxin chemicals, having minimal impact on the environment. Number two, snow and ice removal. Deserts like calcium chloride, sodium chloride have effects on vegetation and water streams. So project teams are expected to set performance benchmark to minimize the usage of these dangerous chemicals while maintaining effectiveness in snow and ice removal. So the management plan should control chemicals and also promote the use of environmentally preferred options for snow removal. Number three, integrated pest management. This essentially talks about instead of just applying pesticide, this is an approach that promotes control, monitoring, and reporting. It is a responsive approach to pest management, and it's to avoid the traditional landscape management strategies of just application regardless of the assessment done, or the impact on other areas without infestation. So that is what the integrated pest management IPA is all about. Now the third strategy under the sustainable site category is the reduction of used island effect. Now, urban areas are known to experience high temperatures due to thermal absorption, which is expanded by narrow streets and tall buildings that restrict movement of air, resulting in the heat island effect. This causes peak energy demand, which increases the cost for air conditioning of those buildings, increasing air pollution, and by so doing, also contributing to greenhouse gas emissions. Factors that contribute to the heat island effect include the use of dark surfaces and materials with heat capacity abilities and thermal conductivity. The materials used for the road: asphalt, pavement materials, concrete roof materials, and roofing sheet of dark colors. Now, the benefits of reduction of heat island effect across the three bottom lines are also listed. Now, this illustration gives us an idea of the effect, because it's an effect of the heat island. You can see examples like heat from the road surface, temperature increases because of the heat from vehicles, heat from the building surface, heat of vaporization, which also makes temperature to go down. So different sources from the built environment having different levels of impact on the heat island concept. Now, there are several strategies identified by LEED to reduce the heat island effect. I mentioned them. Here, I mentioned several. Using existing plant, trees, or vegetation to provide shade so that there's not direct access of sunlight, as it were, to those hard surfaces. The use of solar panels, vegetation, or materials with high solar reflective index values to provide shade from structures. Now, the idea of underground parking spaces is also encouraged, as well as undercover parking spaces with a roof material that has high SRI value. Also, there are innovations around pervious pavement materials or materials with high SRI values, vegetated roads, or use of materials with high SRI values, and of course, minimizing development footprint. Now, we talked about SRI, and then you need to be sure that the reference standard by which it is calculated is ASTM E1980. ASTM E1980. That you can see what the solar reflectance index it's all about. You read that up on the slide and you pay attention to that as we proceed. And there's a difference between that and the solar reflectance. The solar reflectivity of a material refers to its capability to reflect solar energy from its own surface and redirect it back to the atmosphere. Now, this ranges in value from zero point 0.0 to 1.0, right? And this is important because you're still going to make some kind of reference to this. Okay, now you need to pay attention to this. Um, there are key information that are facts that must be handy to you in your preparation. Now, to mitigate the heat island effect and ensure accurate results, LEED standards require materials that are vulnerable to pollution and that to consider SRI or SR values. Their SRI or extra value must be carefully considered. SRI is the most effective method for measuring a roofing material's ability to reject solar heat. And for non-roofing materials, the materials, no, for shade and all that. The appropriate metric is the solar reflectance. LEED establishes additional prerequisites for the lowest acceptable SRR index for different types of roof type categorized by their slope. Okay, so the low sloped roof, which is roof that is less or equal to 2 ratio 12, and an initial solar reflectance index of 82, right? After 3 years, the aged solar reflectance index is not expected to be lower than 64 for low sloped roof. For the steep sloped roof or the high sloped roof, on the other hand, which has a slope that is greater than 2 to 12, the initial SRR of 39 can be allowed to decrease to 32 after 3 years of aging. So pay attention to these figures. They are not illustrations, they are facts of the benchmark that LEED engages to define acceptable roofing and non-roofing response to heat island reduction strategy. In also reducing the heat island effects, we talk about the building footprint right from the stage of design. It is important to prioritize minimizing the development footprint to curtail the adverse impact. That's why we talked about earlier chapters vertical development as against horizontal expansion. Right? So the general approach is to minimize both the building and the development footprints. This can be achieved by adopting a vertical expansion approach instead of horizontal expansion. Alright, another approach to reducing heat island effect is the green roof, which are rooftop spaces covered with vegetation and other layers such as waterproofing membrane, filtration layers, irrigation system that create a habitable area on top of the buildings. So this is another way to ensure that heat island effect is reduced in your green building. And you can see a demonstration here, illustration of the construction details for green room, the formwork, which is the structure to guide what is coming on top of it, hydro insulation, the protective layer, the draining layer which sees runoff, the filtration layer, and of course, you have the vegetation layer. Another strategy is shading. To reduce the impact of a project on heat island effect, consider shading non-roof areas using materials with high solar reflectance index value. Remember, you said for roof measures, you talk about SRI, which is solar reflective index. And then for non-roof strategy, we talk about solar reflectance. So shading can be achieved through vegetation or solar photovoltaic cells. Um, this will cool down the shaded areas, reduces solar heat gain. It has a way of decreasing the overall contribution to heat and energy. Of course, with the photovoltaic cells, you also harvest electricity. The number four strategy under the sustainable site category is rainwater management. Now, this is important because the current conventional approach, widely used, has been detrimental to water streams because it is based on just collecting as much water as possible and then sending it all the way to the drainage system, causing substantial disruption, and pollution. So, to promote natural hydrology and minimize negative impacts, there's what we call LID or GHA, which is low impact development and green infrastructure respectively. The strategies that are being engaged to properly manage rainwater. We'll still talk about a few of those low impact development strategies for better understanding. They have benefit across the sustainable social and economic triple bottom line um, definition. All right. Low impact development. What are the advantages? Like I said earlier on, this is employed to manage the generation of rain and stormwater. By utilizing these, several benefits accrue, as for example, decrease in infrastructure costs, reduced life cycle expenses, plus greater marketability, which also speaks to the value of the property. You are achieving the following when you use the low impact development approach: reduce stormwater volume, enhance water quality because the water is no longer being polluted by what is thrown to the drain. You conserve water for various on-site uses, irrigation, even the toilet facilities can be, you know, serviced from some of the salvaged water. And then you control the peak flow. Now, we'll mention a few of the sustainable low impact development strategies, and you need to also pay attention to the topics we are going to be mentioning now. Power retention cell, you have the vegetated soil, you have the permeable pavement, and then the accessible permeable pavement types include permeable asphalt, take note of that, open concrete, block pavers with 50% or more opening, vegetated grids that are popularly used in gravel and natural stone. There are more LED techniques which include cisterns and rain barrels, green roofs like I mentioned before, disconnected downspouts, tree box filters, retention facilities, and relevant landscaping. They are all low impact development strategies. Now, reusing of rainwater is also a great way to reduce irrigation costs by collecting and storing rainwater in systems and rain barrels. LEED promotes this very well under the rainwater management strategy of the sustainable society. Finally, we talk about the light pollution reduction strategy under the sustainable site category. And this is it gets interesting because you're wondering how much impact does light have on the environment. You'll be interested to know that as much impact as the previous issues that have been discussed. Now, urbanization has led to the emergence of light pollution. This has had several adverse effects, including health problems, disturbances and distortion of the ecosystem, and other issues. Now we have concerns like light trespass, over illumination, glare, light clutters, and sky glow. Furthermore, Light pollution contributes to energy waste with maximum health. It can also affect astronomy. Now, the benefits of reducing light pollution also cut across the triple bottom line. You need to pay attention to this because, like you said, part of the examination will focus on application, not just recall. Application, how you're able to apply the knowledge to apply the knowledge that you have gained by interacting with the subject of sustainability and the expectations of USGBC through LEED would need to be demonstrated in the examination hall. So questions would be framed in such a way that it is your understanding of the circumstances for application of the knowledge that will be tested. So that's why you need to pay attention to the intent. Always understand that there is a mind behind every strategy that is being proposed by LEED. Now, light pollution now in details. Glare, whether this is from artificial or solar sources, it can cause serious visual impairment, discomfort to the eyes, ocular pain due to its intensity and unregulated nature. For light trespass, this happens when light extends beyond property boundaries and negatively affects neighboring homes and areas. So you need to pay attention to the definition of these particular keywords and the impact they have on the road. Sky glow is different from glare. It often happens in crowded places, resulting from both direct light and reflected light on illuminated surfaces. The strategies that have been identified here to address the issues that have been mentioned. And of course, the reference standards we need to take note of are also shown in that information. So we also talk about lighting design, um, choosing energy efficient fixtures, fully shielded fixtures during the design phase will reduce energy consumption. Light fixtures are expected to have shielding and not emit light directly. So this is important in determining the specification of your lighting fixtures. Lighting control. A feasible approach to indoor lighting would be to incorporate control systems that automatically switch off the light in unoccupied rooms. They respond to proximity to avoid unnecessary energy consumption. This already exists in several places. At the lighting zone, take a note of this as a reference standard. Heisner RP-33 IESNA RP-33. This is the reference standard for guiding the classification of the appropriate lighting zone for your project. So you need to take note of this, but like I mentioned, all the keywords are still going to be put together in the bonus chapter of this lecture. As we begin to round up, you need to understand the kind of developments that define the lighting zones. And there are four zones. The light zone one is dark. This is for developed areas within national parks, right? State parks, forest land, and also rural areas. Zone 2, which is low, not totally dark. And this is majorly residential zones, neighborhood business, and all that. Now we have the medium before the cloud, which addresses commercial and industrial areas and high density residential areas. And finally, the high zone features the major city centers and entertainment district. Now, pay attention to these four zones. Don't forget the reference standards and method. You need to be familiar with it. The next part of our lecture will touch on water efficiency. I'll see you there.